Hello, everybody. My name is Jeff Lukens, and I'm coming to you from Sioux Falls, South Dakota, where I was a high school biology teacher for about 35 years in a public school here in Sioux Falls. And after the 2012-13 school year, I retired. And since that time, I've been doing anything but lounging around and doing the retirement thing. I've been working with teachers in their classrooms and doing conferences and so on, helping them learn how to use Texas Instruments technology. And some of the technology that we're going to be using today is part of that, those trainings that I do with teachers. And we're going to be gearing our time together today around a device and around a piece of software that work with what's called TI-Nspire, which is a graphing calculator with a whole bunch of really fancy stuff that it can do, and a lot of curriculum materials and so on that can be used on the graphing calculator. One of those pieces of curriculum material is something little did we know how timely this would be a few years after this activity was created for high school science classes. And this is Zombie Apocalypse. It's from an umbrella of activities that are found free on TI's website. And this umbrella of activities is called STEM Behind Hollywood. And the zombie activity was the first activity under this umbrella of STEM Behind Hollywood. And it has become a very, very popular activity. And I think you'll see why. Kids love it. Teachers love it. When we present this at conference sessions, the participants just eat it up. They think it's, no pun intended, eat it up, zombies, you know. As I mentioned, this is one of several activities under the STEM Behind Hollywood umbrella. So here's our first page of the activity. We have a title page here, and it talks about how disease spreads through a population. And I think right now you're probably going, that sounds sort of familiar with a situation that happened starting in about February or March in the United States and worldwide. So this is, as I mentioned, a really timely activity. But this first page is a real attention getter for kids. You have this guy who is clearly, it looks like three people, but this is supposed to represent a person who is turning into a zombie. And he goes from a fairly normal guy holding his stomach to one that's a raging zombie looking for somebody's brains to eat. Now, so let's take a look at the next page. And I'm just moving my mouse to the top of the screen here and just clicking on these little tabs, just similar to a PowerPoint presentation, but clicking on these tabs and moving from one page to the next. One thing I always do with students and with adults is say, are there any words on this page that you think students may not know, or they may not be that familiar with? They may have heard of them, but they may not be that familiar with them. And most people on this page pick out that word right there. Now, many months ago, when the COVID-19 pandemic started, this was an even more foreign word to people. But now we hear about epidemiologists all the time. I mean, it's sort of backed off a little bit, but we still are hearing about epidemiologists. So when the students say, yeah, that's a word right there I'm not that familiar with, what a great opportunity as a teacher to say, let's talk about a little bit of vocabulary here and talk about a potential, not just vocabulary word, but a possible career choice for people. I know when I was a kid, which was a long time ago, when I was a kid, I never had anybody I knew said, oh yeah, I want to be an epidemiologist when I grow up. Well, nowadays, because of the infectious disease piece of the realities of our society, epidemiology is a pretty big deal. And it's an opportunity for kids to say, oh, wow, I didn't know there actually was a career opportunity for me there. So here we have this word, epidemiology. And some other things to point out here. We have a virus. Okay, we're going to call this zombie, the pathogen, if you will, that causes zombieism. We're going to just say it's a virus. Okay, and it's discovered in the brains of humans, and it turns them into zombies. So we got these epidemiologists who are trying to figure out what to do about this, how to diagnose it, how to prevent it, how to cure it, whatever the case may be. But here's some other really amazing things that we wanted to make sure we built into this. And even though zombies aren't real, and even though this is a made-up scenario, we tried to put in some realistic metaphors, if you will. For example, this one right here. The virus is an airborne virus. In other words, it spreads through the air from an infected person to a non-infected person, transported in saliva droplets of an infected individual. So saliva droplets are spewed out when somebody sneezes or coughs, or even if they talk. There's some words that people can say and some sounds that could cause saliva to be put into the air around the person that is doing the talking or sneezing or coughing. Now, one thing to bring up here with students is, hey, are there any real human diseases that are transported in this way or transmitted in this way, airborne? And I would argue that the two most common diseases in any school are transmitted this way, and those would be influenza, which is transmitted like this, and also the cold virus or rhinovirus, which is transmitted through the air as well. So we have some reality here, even though we're talking again about this made-up scenario of zombieism. Let's go to the next page, on page 1.3. So these four parts of the brain, we're going to say that these are the parts that are affected by the zombie virus. And I would guess that most people, even most young biology students, or even in 8th grade or 7th grade when they take life science, have probably heard of one or two of these four parts of the brain. The cerebellum is certainly a part that most of them have heard of. The cerebrum is probably the part that they've heard of the most, and they don't see that on here anywhere. There's no cerebrum listed, but the frontal lobe, this one in green, is actually a part of the cerebrum. The other two parts that we're going to say are impacted are the hypothalamus, which is the part of your brain. It's embedded very deep, right in the middle of the brain. And one of the things the hypothalamus does, and the hypothalamus does a whole bunch of stuff, but one of the things it does is it is the center for appetite control. So, I mean, if you have like a really, really crazy big appetite, maybe you can, blame the hypothalamus for that. I don't know. But in a zombie, zombies never seem to be satisfied with how much they've eaten. They just are always hungry. So the hypothalamus is messed up by this virus. The other one that's kind of a fun word to say is the amygdala. And that's actually right next door to the hypothalamus in the middle of the brain. And one of the zombies' characteristics and distinguishing characteristics is they're not very happy. I was going to call them people, but they're not very happy beings. They're ticked off. They're angry. They're mad. They're always on the hunt to kill people or eat people or whatever. And the amygdala is that part of the brain. Sometimes the amygdala is called the crocodile brain because in a reptile, like a crocodile, the amygdala is actually quite large in comparison to the rest of the brain. So, I guess that has something to do with them sort of always being mad or ticked off or whatever, the reptiles it is. So here's our four parts of the brain that we're going to be saying are impacted by this zombie virus. And here's where they are located. And if you'll notice, this is a very subtle thing, but it's a big deal. These parts of the brain are color-coded. Color is a great learning motivator. And all of these four parts of the brain are color-coded. And we were sneaky and said, okay, the frontal lobe, we're going to make that phrase in green. And so we're going to make the frontal lobe green, and the cerebellum is going to be blue, and so on. And there we have them. And the hypothalamus and the amygdala are buried right in the middle of the brain, not too far anterior to the brainstem, which is right here. So there's the location, little anatomy here, not a lot of physiology here. Physiology is what things do, what parts of the body do. Anatomy is where they're located. So here's the anatomy of those four parts of the brain. If this particular part of the brain were impacted by this virus, what would be the outcome? Okay, what would be the result of that? So the cerebellum, zombies kind of clumsily shuffle along, and but the classic zombie symptom is kind of just shuffling forward, and that would be the result of a malfunctioning, if you will, of the cerebellum. hypothalamus. They have insatiable appetites, is another word, another vocabulary word that some students may not know. Good opportunity to bring that up. Frontal lobe, amygdala, and so on. Now, what are some human conditions that actually do occur where somebody, for example, clumsily shuffles forward or loses muscle control? And with the cerebellum, with muscle control being its main function, we could talk about all of the series of what are called neuromuscular diseases like ALS or Lou Gehrig's disease, muscular dystrophy, MS, and so on. There's a lot of these neuro, which means nerve, muscular, which obviously means muscular. So a nervous system, muscular system malfunction. And actually the malfunction in all of those neuromuscular diseases, in most of them, actually happens in the nervous system, but the resulting display of that nervous system malfunction is in the muscular system. So it's a great opportunity to have kids do some research, like what are some diseases, some human diseases that actually manifest themselves with these symptoms. Poor problem solvers, you know, we could argue that we know people like that. I know people have accused me of that before. And then this amygdala, the zombies just aren't nice. They're full of rage. And a lot of times if you teach in high school, athletes have heard of one of the side effects of steroids, of anabolic steroids that are taken by an athlete, is that they've heard of roid rage or something like that. So you'll have them actually talk about things like that, which is kind of a cool deal when they start to see some of these familiar conditions, but playing out in zombies. Okay, so that's pretty cool. All right, so let's get on to page 1.6. Here it is. Here's our guy, who was a fairly normal looking guy. And here's the brain of this person, presumably. And so I'm going to go ahead and click on this play button, which is right down here. One of the things about TI-Nspire, not only the software that I'm using on my computer, but also the handheld, the TI-Nspire graphing calculator. This looks exactly the same on that calculator. So the next thing you're going to see me do is something that you may not have ever seen a graphing calculator do before, which is a simulation, an actual movement of something. So I'm going to go ahead and click on play, and I'm just going to let this run through a couple of times, and we'll see what happens to this guy as he goes from stage 0. So here he is. He's a human with no infection, and now we're going to go ahead and infect him. And I'm just letting this run through. I'm not clicking on anything right now. This is a loop that runs through continuously, and it will run continuously until we stop it. So you can see this guy as the stages progress from stage 0 to stage 4. Clearly, he's changing on the left side. His face is changing. He's getting these lesions all over him. He's getting ticked off and looks like he's full of rage. Meanwhile, on the right side, we see the result of the virus, or the impact the virus is having on his brain. Here's his frontal lobe and the cerebellum that are shrinking up, which is the fancy word for that is atrophy, or can be atrophy. Meanwhile, the amygdala and the hypothalamus in the middle of the brain are getting red and infected. Okay, now we can actually step through this one stage at a time. So I'm going to pause it after stage 1, and you can talk about that with the students and just take a look at what changes have occurred in this guy from stage 0 to stage 1. There's stage 2. We see him looking a little bit different. I'm just clicking play and then pause again. Here he's starting to look a little scarier. And then finally, when we get to stage 4, he looks beyond scary. He looks like he's a full-fledged, full-blown zombie. Okay, so that's you know, if you didn't have their attention before, you certainly have their attention now. This is a really, really cool deal for keeping kids on task and keeping kids' attention. All right, so let's take a look here at the next page. We just watched the guy turn into a zombie. From here on, you're going to be able to relate to the middle part of the year 2020. So, as with all infectious diseases, we always assume that the virus started with one person, or the disease, if you will, had to start somewhere. And so the background of this is we're going to say one person was the initial zombie impacted by the zombie virus. And that person, because of the contagious nature of this virus, has the opportunity to infect other people. So we're just going to make some, made up rules basically. It's estimated that each zombie then infects an average of 2 people per week. Okay, so we just arbitrarily made that up. And the number of, another made up word, zombified, the number of people who are zombified grows and grows and grows. So we're going to take a look at the graph. Now, here's what kids do. They'll look at the bottom of that page and they'll go, wow, I want to go look at that graph and see how scary it is. And at first, so I'll move ahead to page 1.8. At first, it's like, oh yeah, that's really scary. They're not frightened by that graph because it is a picture of data that hasn't been analyzed yet. But as they take a look at this graph, and as the teacher, that's you, as the teacher talks about this and what it means, then this graph sort of becomes, they kind of catch their breath a little bit. Because not only does this work in the made up case of zombies, but we have seen this happening in the last many months in the US and also in the world with COVID. So when you could bring up things that prior to COVID, we never really had heard this phrase, flatten the curve. And you can spend some time talking to the students about what that means in context of the spread of a disease. Here, right now, this looks like it's an out of control exponential growth, if you will. But flatten the curve means get this growth, get this rate of infection to slow down so that there's not as many people who are infected. And all these precautions were taken with COVID that were designed to slow the growth of this virus down and to flatten the curve. Now these down here, one fun thing to ask kids is to say, what does it look like is happening between week 1 and week 5? And the answer that they typically come up with is, well, nothing is happening. Well, we know better than that. Something had to be happening, otherwise we couldn't have shot up like this to week 10. So if you hover over each of these little data points, you get an ordered pair or two numbers in parentheses. The first number is the number of weeks. Second number is the number of zombies. So you can see that the weeks are going up by 1, but the number of zombies is increasing faster and faster and faster at an exponential rate. So there's our scary graph, not only for zombies, but also for any infectious disease. And again, the current one, the COVID-19, incredibly similar to what we just looked at. This actually is a photograph from 1918 in a makeshift hospital in Kansas. So if you are a Kansas resident, big shout out for you. This was in 1918, and people tend to not really remember what was going on in 1918 besides World War I, which was bad enough. But at the same time, we had an influenza pandemic, actually, or epidemic, a worldwide event that is estimated to have infected about 1/3 of the entire world's population back then. Now, to be sure, the population was way less, but it's estimated that, check this number out, 50 million people died from this influenza outbreak and this influenza pandemic. 50 million. Now, the population back then was probably, I would say 2 billion. I should look that up. I should know that, but another great opportunity for research. So you think about the tumultuous time this had to have been. Not only World War I going on, but also this pandemic, this influenza pandemic that resulted in the deaths of literally millions of people. Now, kids are funny because they will say things to you like, well, why didn't they just get flu shots? And I know you're probably snickering, laughing, whatever right now, But think about the kids' paradigm. Think about the world they live in. They have probably been getting flu shots since they were babies. And that's part of their life. That's part of their reality. 102, 103 years ago, that wasn't part of the reality. There were no flu shots, which again is a testimony to the effectiveness of vaccines on the survival rate of people and also the lifespan of people. So rather than just belaboring this, but again, look at the great opportunity to do some research on this particular epidemic or pandemic. The last thing we're going to do in this activity is we're going to do another simulation and show a graph that measures and then plots this phrase called virulence of this zombie virus. Virulence basically just means how easy is it to get this from one person to another. For example, chickenpox, which again, students probably never had chickenpox because they get vaccinated against chickenpox, but when I was a kid, we all got it. And chickenpox is incredibly virulent. I mean, it's not deadly. It's not it's not nice to have chickenpox, but it typically doesn't cause people to die. So, but it's amazingly virulent. It's very contagious. So on this next page, we're going to actually control the virulence of the zombie virus. And we do that by looking at the bottom left-hand corner of this screen. And I can toggle, I'm just clicking on these arrows, and the virulence goes from 1 to 10. Okay, so we'll just run this a couple of times and we'll take a look at the difference. So I'll just go down to 2. We'll say we're going to make this a virulence of 2. And here's one graph, and here's another graph. So I'm going to go ahead and click on play, and we're going to watch what happens. And I trust me, my hands are not touching the computer right now. This is running on its own. This is a simulation that is running. And you can see both sides of the screen are changing. The red boxes are filling in greater and greater number on the left, and the graph on the right is actually plotting the data, and there it's done. Okay, so we can take a look at this graph and say, well, to get to 1,000 or 16,150, it took us 25, and we didn't put a unit of time here. Let's just say 25 weeks, whatever. So it took us 25 weeks at a virulence of 2. So I'm going to go ahead and reset this. And this time I'm going to crank that up to 10. So I'm going to make this really, really virulent. Now you'll see something right away that looks different. And I'll go ahead and click play and just, you can watch this. Whereas before it took us much longer to complete this simulation, this one's going much faster. Even in the real time thing, it's going much faster. So we're almost to the end here. So if I remember right, it took us 25 units of time to max out here, and here it only took us 20. So a great strategy with students here is to have all of the virulences represented. Just have each kid do a different virulence and then compare them all with the people who are sitting around them. Now, while we were doing that, this is one of my favorite graphs. While we were doing that, another graph was being generated without us even seeing it being generated. And this is a graph that shows the number of, let's start with the red one, the number of zombies. So the number of zombies is increasing, 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 and then it's starting to level off. The rate of infection is decreasing because we don't have as many people to infect anymore. Whereas the numbers of humans that are normal still, that are not zombified, is decreasing until finally we level that off. We don't have as many people to infect, so the rate of infection is slowing down. Now, what a great opportunity, especially with this red graph here. If you're a biology teacher, we all use graphs like this in our curriculum. And I'm thinking in specifically about when we talk about ecology, we talk about population growth, a J-shaped population curve that turns into kind of this S-shaped population curve. And The result of that, or the cause of that, are these things called limiting factors. And there is a carrying capacity of every environment for every different type of organism. Every species of organism, there's a different carrying capacity in the environment. That's a great way to model that and ask the kids, well, why is this leveling off? And the reason it's leveling off is we're running out of people to turn into zombies. I mean, if you think about COVID, eventually the curve was going to flatten. I mean, whether we tried to do it or not, eventually the curve would flatten. Because if everybody on the planet got infected with COVID, the rate of infection would start to slow down. I hope that makes sense. Because eventually the curve's going to flatten. We just try to flatten it using means to keep people safer and to keep the hospitals from being overcrowded and so on. So this is a really cool graph too that represents the zombies and the humans. Now, if you are a math teacher, or if you know a math teacher and you show them this graph, especially if they teach Algebra 2, they could teach a lot of content right off this graph. And one of those pieces of content they could teach is, where do those two plots cross each other? And if they can determine that and calculate that, that's called solving a system of equations. And that's a big, big deal in second semester Algebra 1 and first semester Algebra 2. That's a huge, huge deal. So there's some graphs that we can look at as we go through some of the growth and the increase in the number of zombies and the decrease in the number of normal humans. And I believe that's it. That's our last page right there. And this just kind of gives some credits. I would like to call out, here's Dr. Schlossman, Stephen Schlossman, that professor at Harvard Medical School. If you're like really into zombies, if you're a zombie person, Dr. Schlossman wrote this book called The Zombie Autopsies, Secret Notebooks from the Apocalypse. There's a great backstory with this book that I won't share with you right now. But if you're into zombies, this is it's a quick read. It's very entertaining. It's kind of scary and very, very cool. And a kind of a spoiler alert here is Dr. Schlossman actually writes about finding a cure for zombieism. And if you're a chemistry teacher, I'll tell you, it has to do with the pH of the blood, which is a really, really big deal. pH is a huge, huge deal. Okay. So let me go ahead and stop sharing, and there I am again. And I just want to thank all of you for watching our zombie apocalypse activity. I hope you can make some good use out of this. And again, it's found for free on TI's website, and the website is education.ti.com. I'm sure whoever is sharing this video with you will share that website with you and guide you toward where those activities can be found. All of them are free. You can just download them right off the website, and Zombie Apocalypse is one of them. So thank you so much for attending this. And hopefully, once things calm down here with COVID, hopefully you and I will get to meet each other face-to-face somewhere. So have a great school year. Have a great day.